All right, we're live and I'm admitting everyone right now.
Okay, great.
Just a few seconds to let everybody get in.
Sure thing. Hello, everyone. We're going to take 1 second. Hi, I'm Ian. We're going to take 1 second to just let people enter and get settled in, and then we'll get to the main event. I'm in class right now, so there's a giant picture of myself being projected onto the just off camera on the board, which is funny. Okay, on that note, it's 7:05, so why don't we go ahead and get started? Hi, I'm Ian Olasov. I curate this series, Philosophy in the Library. It's part of Brooklyn Public Philosophers. It's ongoing public philosophy event series for a general audience. That's a partnership between the philosophers of the greater Brooklyn area, as I like to say, and the Brooklyn Public Library. I'm really glad that Kelly Dine is joining us to speak today. I only found out about Kelly's work rather recently, but I'm glad I did. Kelly works on one of my favorite philosophical problems, which is about how meaning arises out of just physical stuff happening in the world, and how we use the concept of things being meaningful to explain animal behavior, to explain physiology, to explain all sorts of stuff that we see and experience. And I realized after learning about Kelly's talk that I think we've been running this series since 2013, but we haven't had any philosophers talk about this, one of my favorite philosophical problems. So I'm really excited for this today. So on that note, Kelly Dine, take it away.
Thanks. Yeah, thanks for inviting me to do this. It's a privilege to be here. I'll start my screen share. All right, so everyone should be able to see my presentation right now. Get any like emoticon thumbs up or anything? Or is this? Okay, nice. All right, so this talk's called Brains, Ants, and Meaning. My name's Kelly Dine. I'm a postdoc at the University of Kentucky in Lexington. And I'm going to start this talk with a vignette. It's one that some of you have probably heard before. It goes, there's two young fish swimming, and an older fish comes by and he says, "How's the water, boys?" And one of the young fish says to the other, "What the hell is water?" And the moral of the story is that some things can be so familiar to us and they can pervade our lives so thoroughly that they become invisible to us, that we're unable to see the strangeness of them anymore because we're just constantly surrounded by them. And that is the case, I believe, that humans are in when it comes to the concept of meaning. So human life is totally full of meaningful relationships. Our thoughts are meaningful. I mean, there's things happening in our head and they're somehow about other things in the world, or maybe things that have never even existed. the words we speak are meaningful. They're supposed to refer to things. And it's pretty mysterious, sort of what that relationship is or how it's supposed to work. So the big question that we're going to be looking at tonight is, what is meaning? And at the very least, up front, we can say a few things about it. It's a relationship between two things. X means Y. So X in this case being the sort of vehicle of meaningful content, and Y being the meaningful content. X means Y. Some related concepts: representation, reference, indication, semanticity, aboutness. And each one of those words might seem mundane or unproblematic, but behind each of them, philosophers recognize a common puzzle. And it's a millennia old puzzle because, despite thousands of years of inquiry and wondering and philosophizing, there is no consensus account about how one thing enters into a meaningful relationship with another thing. And so the problem of meaning, when I think about it, is really like a labyrinth with many entrances, because the problem is relevant to so many different academic disciplines and methodological approaches. In one way or another, philosophers, historians, anthropologists, linguists, cognitive scientists, they all grapple with problems of meaning and interpretation. They have to know, what makes it the case that one thing is about another thing, and how am I supposed to verify that relationship? And in this talk, this context that we're going to be interested in is the behavioral sciences. So in the behavioral sciences, scientists will perform investigations, and then at the end of them, sometimes they ascribe meaningful content to the organisms that they're studying. And there's a rough hierarchy of different kinds of meaningful content. And at the very top, of course, it's humans. With the most sophisticated kind of meaning is propositional content. So our thoughts, our spoken sentences can express propositions like, it's cold, or no, it's not really that cold. And then beneath that is conceptual content. Scientists ascribe conceptual content to animals, sometimes like dogs or maybe zebrafish. And since we don't have a first-person perspective on what it's like to be a dog or a zebrafish, scientists usually take some form of sophisticated behavior to be evidence that the animal uses mental categories and is engaging in conceptual thinking. Then at the bottom of the hierarchy is something I'm calling primitive content. These are animals that sometimes are right at the borderline of what scientists are willing to ascribe content to. I have an ant here. That's the example we're going to be using tonight. And these ascriptions of primitive content are often framed in terms of information processing, or at least they have been ever since the sort of computational revolution in the 20th century. One example of what that would look like here is a scientist will do some experiment, and then at the end, they might say something like, ants get information about how far they walk by counting steps. And this is an ascription of meaningful content because he's saying that somewhere on the ant, there's some mechanism that's recording information about how far the ants walked. And it's that aboutness there again, that's the mystery. And in case you want the sort of like more practical reason to care about ascriptions of meaning in insect navigation research, should note that artificial intelligence designers and roboticists are looking at the research that we're going to be analyzing tonight, and they're finding inspiration in it to design drones that can navigate autonomously. So they're actually reading these research reports, looking at the way scientists are characterizing the mechanisms underlying animals' navigational capacities, and then they're sort of translating that into robotics. And to take a step back for a second, this is all sort of part of a larger movement in the history of science. At the end of World War II, the end of the 1940s, mathematicians, Claude Shannon is the one in particular, he came up with a mathematical theory of communication, and now we just call it information theory. And there was a big sort of movement, there was feeling, people were saying that this new formal concept of information is going to totally revolutionize the behavioral sciences, and that this new mathematical concept of information is the key that's going to unlock a unified theory of behavior. And we can use the same theory to understand human behavior, animal behavior, machine behavior. But that revolution never really came to fruition. And I believe one of the reasons is because this mathematical theory of information didn't say anything about meaningful content. So it didn't address the mystery of meaning that I started this talk explaining. The theory assumes that information has meaningful content, but it just doesn't say anything about how we're supposed to determine it or verify what that content is. All right, so what the question we're going after right now is, what do scientists mean when they ascribe meaning to animals? And we're doing philosophy. There's a lot of different ways to do philosophy. In the Western tradition, people usually split it up into three kinds. Continental, it's like Europeans. If you've heard of existentialists, that's an example of continental philosophy. Then there's analytic philosophy. That's really popular in the Anglosphere. So like England, America, Australia, that's a really mathy kind of philosophy. They might approach this problem by coming up with some kind of account where they say, you know, something has meaningful content if and only if, and then they list a bunch of criteria that something has to fulfill. And then there's this third tradition called American pragmatism. And that's the sort of inspiration that I'm using to answer this question tonight. And in particular, what I'm riffing off here is a sort of framework for analyzing scientific investigations that was put forward by the American philosopher Charles Peirce. I had his picture on the previous slide. And if you're interested in the sort of ideas I talk about in relation to him, there's this great paper he wrote in 1878, Popular Science, called How to Make Our Ideas Clear. And it describes this. And so Peirce's idea here of how scientific investigations work is that in the beginning, scientists enter into a state of doubt, and it's an irritating state. To ameliorate that irritation, they perform investigations. They do things in the world. And sometimes at the end of those investigations, they have outcomes that they interpret as evidence that justify a belief. And the belief ameliorates that initial state of doubt. And the belief also guides their actions moving forwards, especially in the sorts of situations that occasioned that initial state of doubt at step one. And Peirce's idea here is that if you want to get clear about the meaning of a belief, you look to step number 2 and step number 4. You look at the things that someone did to justify that belief on the front end, and then on the back end, you look at how that justified belief was guiding their action after they fixated on the belief. All right, so the example, I'm just going to go over like a sort of easier example before we get into it. The example was the belief is this rock is hard. And so we might wonder, well, what is hardness? And so let's use this Peircean method to clarify what the concept of hardness is. And first we look at the investigation, the things people do to justify beliefs about hardness. And if you look into the geological sciences or material sciences, there's something called a scratch test. And it's a really simple idea. It's just that you take two different things and you rub them on each other. And the one that leaves a mark on the other one is harder than it. So in this picture I have here, there's someone scratching a rock with a nail, and the nail is leaving a line on the rock. It's sort of gouging into it a little bit. And so we can say after doing this test that the nail is harder than the rock. What about on the back end? What happens once you justify a belief about hardness? Well, there's all kinds of things you can do. If you've justified a belief that a certain rock is harder than your pocket knife, then you could use the rock to hone the edge of your pocket knife. If you're trying to build something that's going to last a while and be impervious to the elements, then maybe at the end of investigating the hardness of a material, you decide that you can use it to build a wall or a house. Or maybe you want to destroy something. And after you've verified the hardness of something, you use it to break a window. So on this sort of conception on clarifying ideas, what you get is like, what's the meaning of a belief this rock is hard? It's a sort of collection of actions and possible outcomes. There's the things you do to justify it, and then there's all the things that you might do as a sort of rational outgrowth of that justification. All right, so we're going to turn back to the main point here, which is what about meaning? So scientists ascribe meaning to animals. They point at them at the end of investigations and they say that mechanism has the function of recording information about X. And we want to know via a pragmatic explication, what do they mean when they do that? And the example we're going to look at here is in insect navigation research. This is Rüdiger Weiner. He's a German insect navigation researcher. He's been doing it a long time. And he has this doubt. Do desert ants record information about distance traveled via an internal odometer? So that's kind of like a weird doubt to have. It's not the kind of doubt people normally entertain. So I'll give a little background on why he would even think something like that in the first place. And the reason he thinks something like that is because earlier in his career, he established that desert ants navigate via a strategy called path integration, or it's also called dead reckoning. This is basically a strategy that mariners use when they just had the compass, the stars, and a map to guide them on their ocean voyages. So desert ants, they live in this sort of very austere environment, salt pans in Tunisia. Foragers go out and they look for food and they take these meandering paths all over searching. But as soon as they find food, they always make a straight line straight back to the nest, because if they stay out there too long, they're going to die of heat death. And so it's an impressive feat. You know, it's like, how are they doing this? Because they're walking really long distances, especially in relation to how small they are. And Weiner found out one way they accomplish this is by doing path integration. Here's how path integration works. On your outgoing journey, you record the journey as a series of straight lines. And modelers, mathematicians, they would sort of model this process as the lines are vectors. And the vector has two values. The first value is how long is the line, how far did the ant walk? And the second value is what direction is the line pointing? What direction did the ant walk away from the nest? And the ant is recording her outgoing journey as a series of straight lines like this. So she's looking over there for food. She's looking over here. She found the food. Now, when the ant finds the food, what she does is she integrates all of those vectors that represent her outgoing journey into a single vector. We don't have to get into the mathematics of it, but it's just a rule that when she performs that operation, she'll always have a vector that is the most direct route from wherever she is back to her point of origin, which in this case was her nest. All right, so she did path integration and now boom, has the food straight back to the nest. So if ants navigate via path integration, they must possess some means of recording information about their direction and distance of travel. That's sort of like what the theory stipulates. And that's how we arrive at this doubt that Rüdiger Weiner had in 2006, 2007. He was thinking, you know, how are ants recording information about how far they walk? And one of his hypotheses was maybe ants walk in such a consistent way that they can count their steps, and counting their steps will be like a proxy measure for how far they've moved. All right, so how did he seek to justify this belief, which ascribes meaning to ants? He did it via a series of experiments called the Stilt and Stumps experiments. Here's how the experiments worked. First, he trained ants to forage at a controlled feeding site. So once the ants are reliably moving back and forth from the nest to the food, back to the nest, then he does the decisive experiment, where he allows the foragers to come out to his feeding station, but once they get there, he either glues stilts onto their legs, which are made of pig bristles, or he cuts their legs in half so that they're on stumps. The idea here is that the longer your leg is, the more distance you travel per step. The shorter your leg is, the less distance you travel per step. So if ants were counting their steps on their way out to the food with normal legs, then once their legs got chopped in half, on their return journey, they should undershoot the distance because now they're covering less distance per step. And alternatively, if you glue stilts onto their legs once they get to the feeding station, then they should overshoot the location of their nest because now they're covering more distance per step than they were on the outgoing journey. And when they performed the actual experiment, that is really what happened. The ants got lost, and the ants on stumps undershot where the nest was, and the ants on stilts walked too far. So what we have here now is a justified description of content. And what I've done in my research is I've looked at a whole bunch of instances just like that. So science is a tradition. It's a lineage of mentors and mentees who pass down investigative practices to each other. And this basic research strategy that I just explained to you, where you train a forager to forage at a controlled feeding site, and then you mess with them in some way. You manipulate their body or you manipulate their environment, and then you watch what happens. That is a research strategy that's going back to Carl von Frisch. If you've ever heard of the honeybee dance language, he's the guy who discovered that. So it's over 100 years old in this sort of tradition of German-speaking insect navigation research. And across the careers of these three men who, each one trained the next, they've all been using this research strategy, and it's consistently allowed them to justify ascriptions of meaning. And so I looked at a bunch of these examples, a bunch of these instances, and I distilled sort of what does it take to justify an ascription of meaning. And here are the two basic rules. So the first one is no information without biological function. And by biological function, I'm just talking about this idea that we treat the living world as being full of traits that are for things. So an eagle's wings are for flying. They have that function to facilitate flight. The woodpecker's beak is for boring into the sides of trees. It has that function. And philosophers of science have been, they've wondered for a long time, well, where does that function come from? Like, how should we think about that? And they've come up with different theories or accounts of how to think about biological function. The most popular one here I have represented by Darwin's head. It's called selected effects function. And the basic slogan behind this account is just that the function of a trait is whatever the ancestral versions of that trait did to contribute to fitness so that the trait got passed down. So in the case of the eagle wing, it's the eagle's wing has the function of facilitating flight because that eagle's ancestors had wings like that too. And those wings actually did facilitate flight in the past. And the eagle's ability to fly was part of the reason it could survive and reproduce and create the eagles that are around today. So that's like the most popular theory of biological function amongst philosophers of science. But there's another one that's called goal-directed function. And on this way of thinking about function, you don't look to the past. You don't look to ancestral versions of something to figure out if it has a function or not. You look to different possible situations. And the often used example here is a heat-seeking missile. So a heat-seeking missile has the function of homing towards a heat source, but it doesn't have that function because its ancestors had that function. It doesn't have ancestors. It has that function because across a whole wide range of different situations, the missile will do whatever's necessary to impact the heat source. It will modify its own behavior in whatever way is required to reach the goal, which in this case is hitting a heat source. And this is a second way of thinking about biological function. And that's the relevant notion of function I've found when scientists are doing these animal behavior experiments to justify their ascriptions of meaning. And we can just think about it really briefly. It's like, did the scientists look to the history of those ants? Did they try to investigate the ancestors of the ants? No, they got a collection of ants that they treated as interchangeable. And then they put them in some different situations and watched the outcome. And that's sort of how you would determine function on a goal-directed notion of biological function. So, all right, the first rule, no information without demonstration of goal-directed function. The second rule would get us a little more in the weeds. I'd be happy to talk about it in question and answer if anyone's curious about it. But it's basically that if the goal-directed function is difficult, and if the animal is still reliably achieving that goal-directed function, then scientists will ascribe meaningful content to that function. And these are really the only two rules. If these two things are satisfied, what I've found is the scientists will ascribe meaning. What about on the back end? Once they've ascribed meaning and it's been deemed appropriate by their research community, how does that guide their action moving forward? What I've found is that it helps them do two things. It guides their actions in at least two ways. One of them is that it helps cross-species comparative theorizing, and the other one is that it helps them come up with new hypotheses. So with the cross-species comparative theorizing, the idea is that once you ascribe meaning to some biological function, it becomes more abstract in a way that's really conducive to comparative theorizing. Like with the case of the Stilts and Stumps experiment, it justified the belief that ants record information about how far they've walked by counting steps. Well, you could just port that hypothesis over to really any walking organism that is a central place forager. You could say that about meerkats, for instance. Maybe they do that too. And you could try to run the same experiment on them. And this is sort of how statements of meaning help you port hypotheses from one animal to another. It creates this abstract space of problems and solutions where there's this basic problem, return home from a search. And then you have a bank of possible solutions. Like maybe you recognize landmarks to get home. Maybe you follow a scent trail, or maybe you do path integration, which was the case that we just looked at. The other one is hypothesis formulation. And I could talk more about this in question and answer too, because it would sort of get in the weeds to be more detailed about it. But the basic idea is that these ascriptions of meaning, like I said at the beginning of a talk, it's like a two-place relationship, at least. There's X is about Y. And when you look at the history of these research programs over the decades, what happens is that they'll do an experiment that specifies X or Y. And then once they've specified Y, it helps them think about X and come up with new hypotheses about sort of what is X. And then eventually they'll do a bunch of experiments and one of them will work. And now they have a more specific formulation of X. Now that specific formulation of X helps them think about Y. And it's this two-step they're doing that becomes increasingly specific. And as they get more specific, they're moving down through mechanistic levels from the behavioral level down into the sort of nervous system level. So just like on the pragmatic view of things, I believe this rock is hard is sort of like this picture is the meaning of that, this collection of verifying practices and possible outcomes. On this pragmatic explication, this is what beliefs about meaning in brain and behavior experiments mean. There's this idea of goal-directed function, difficulty, reliability, and then on the back end, there are these practices of comparative theorizing and forming new hypotheses. And so this is the last slide. To step back from all of this, what I want to suggest is that meaning may not be a very unified concept. And to find out, I think we have to go and look at how different communities of people use the concept of meaning in their lives. So even just within animal behavior research, I wouldn't be surprised if I started looking at a whole different tradition of scientists and I found that they use the concept of meaning in a different way, that they justify it through different practices, and that once it's justified, they use it to accomplish different things. And if we're going to zoom out one step even more from philosophy of science to just philosophy, period, and think about our everyday lives, the concepts of meaning that we employ may be more varied, maybe more sort of pluralistic senses of meaning in our life than we realize, because again, it's like water to us. Thanks for listening. This talk on meaning. Happy to take any questions or comments about my work.
Great. Thank you so much. It's open for questions if people want to ask some in chat. I mean, I guess one question, I'll give myself the first question, one thing that occurred to me is like, do you think that this account, so if it might be the case that, yeah, people use different concepts of meaning in all sorts of different contexts, you know, to explain human behavior, to explain the behaviors of artifacts or whatever. Do you think that there are, is this sort of concept of meaning that you've clarified here strictly internal to like insect behavior research? Or do you think it's like a little bit more general than that? Is this really just about like this one community of scientists like investigating like how bugs move around? Or is it yeah, more general?
Yeah, I don't think it's specific to bugs, but I think if I had to guess, it may be specific to animal navigation research, or at least to investigative paradigms where you're dealing with space and you're measuring space and how an agent moves through space. I think maybe that's like the right level of specificity for matching up this clarification of meaning I've done.
Thanks. Yeah. Other questions? I can give myself one more. Why not? The one possible limitation of the picture of how to clarify the meanings of things that you get from Peirce, that you borrowed from How to Make Our Ideas Clear, is that you know, often there's no single test, and there might be any number of tests or any number of sources of evidence that people can come up with for some claim, and there might be any number of actions that they can justify on the basis of that claim. So you know, if I think it's cold outside, I mean, I can learn about that from going out and, you know, feeling for myself, or I can watch the news, or I can check a thermometer, and I could justify any number of actions on the basis of that. If I want to go skiing, then I'll go, okay, then I think it's good skiing weather. If, you know, I want to stay warm, I'm going to stay inside. So, you know, it seems like the possible sources of evidence for claims like that it's cold outside are really, really broad, and the possible range of actions that you could justify on that basis are like really, really broad. So, and it might just be sort of be hopeless to try to pin them down or think about them systematically. I don't know. This is sort of an abstract or sort of theoretical question, I guess, but it's like, is that right? or like, how do you think if you want to approach clarifying meanings along these lines, like how do you respond to that sort of concern?
Yeah, so there's one way that I'm going to push back a little bit, but then another way that I'm going to bite the bullet on it. And so the pushback way is that first you might think or hope that of all the different ways that you can verify or justify some belief, that there's going to be some common principle or fundamental sort of thing that's tying them together, and that they can all sort of fall under one category. But even if there are different categories that encompass lots of different ways of measuring, for instance, how cold is it outside? It's like one way might be that you actually put, you know, yourself and your body in the environment, and you just feel sort of how cold it is. And you could do that by sticking your hand out a window, sticking your foot out a window, sticking your like nose, it just keeps going. But you like, well, okay, but maybe those all fit under this one category of like using my body as a sort of thermometer. And then there are other ways too. And it might be that if the ways are different enough and there are like widely divergent categories of ways of justifying, then those are different senses of cold. It's like not the same type of cold. And I think that that's the sort of attractive idea. But on the biting the bullet side, I think that this is one of the most unsatisfying aspects of the Peirce's methodology for clarifying concepts. And it's really on the back end when it goes to how does a justified description of some concept guide your future actions? Because then it's really a huge list of things that you might do as a sort of like rational inference from some justified concept. And I think you just have to say that it means that meaning can't be encapsulated and pinned down in sort of neat lists like we might hope that it could.
Yeah, yeah, that's helpful. Thanks. Well, Norb says it's a great session, enlightening, provocative, relevant. Thanks, Norb. But if there are no other questions, I think maybe we can call it here. Thank you so much. This is really interesting stuff. I really appreciate it.
Yeah, thanks everyone for coming to have a listen.
Okay. All right. Bye.